Good morning, everyone. We're going to start by getting logged into Clever. Awesome. Thanks, guys, for being here. I know the world is a kind of tense place right now for many reasons, but just want to take a second to give you guys the opportunity to turn your thoughts and your eye inwards and do a little stress check. All right, so welcome to lesson 21. This is the only actual lesson for week 11 because of our weird schedule. We are talking today about how atoms can vary in what are called isotopes and ions. So, a couple of reminders for you and announcements before we begin. As always, make sure you're checking assignments for grades, for comments, for questions, for returns, whatever. It is a lot of my grading gets done on Friday, Saturday, Sunday, and then Monday. And so be aware to kind of look for a flood of returned assignments on those days. And if you notice that something didn't get graded, or if you redid something after I told you to and I forgot to check it, don't be afraid to throw a private comment in there to kind of like get my attention on that. And it goes directly to my phone, so I always look like at it right away. With the Ed puzzles, remember that the week preview, so this week is number 46, week 11 preview, those are required. If there is a number, a pound symbol, a hashtag, whatever you want to call it in front of an Ed puzzle, it is required, okay? In the same way, make sure that you're always watching the Ed puzzle all the way through. Always remember our expectations. And give yourself some self-love, some appreciation, because you continue to show up every day. You're here right now. You're doing the things you need to do to be successful in the class. And for that, you should give yourself some gratitude. So this week, like I said, isn't a whole lot of new stuff. We're still using the periodic table. We're still looking at the structure of the atom. But now we're looking at what are called ions and isotopes. So at the end of the lesson, there will be 2 new assignments that actually I'm going to walk through with you with a little bit. So far this week, we've had our Ed puzzle preview as well as the check for understanding. But again, after this lesson, there will be 2 new assignments for you to work through. Remember that it's super important to watch these live lessons or recorded lessons before you try and do those assignments, because trust me, you will be super confused if you haven't watched this first. So if you're here now, good job. All right, so it might be a good idea in our unit with periodicity, this will continue to pop up. It might be a great idea to have a periodic table available. It's kind of one of those things that you should expect to use on a daily basis. If we were in class, you would have your own periodic table in your binder that you would pull out and use every single day. All right, so let's start with this warm up. There are 4 characteristics listed, on the left side, and each of them describe 1 or 2 of the subatomic particles. So we're going to start with that. Which particle determines the atom? Which particle is calculated by taking the mass and subtracting the protons? Which particle is negatively charged and, if equal to the protons, makes for a neutral atom? And then which 2 particles contribute to the mass? Great. So the particle that determines the atom is our proton. Mass minus protons give us the neutrons. The negatively charged particle that, if equal to the protons, makes it a neutral atom, is the electrons. And then our protons and our neutrons add together to tell us our mass. Great. So that's understanding, and basic knowledge is super important for us moving forward in understanding how atoms change when you change some of those things. So today we're talking specifically about isotopes and ions. So let's start by take a look at these 2 screenshots and make some observations. So what are some things that you see are the same, and what are some things that you see that are different? So what you guys brought up is that you see that both atoms are beryllium. They're both Be. They both have 1, 2, 3, 4 protons. They both have 4 electrons. They're both neutral atoms. Okay, those are some things that are the same. Some things that are different, we notice that this has 6 neutrons and this only has 5 neutrons. This has 10, and if we think about what this means it has a mass of 10, and this has a mass of 9. This one is unstable, and this one is stable. The only thing that changed is that this has 1 more neutron than this one. What this describes are isotopes. So isotopes are when you have the same element, So the same number of protons, the same element, but the neutrons, are different. And because the protons and the neutrons tell you the mass, if you change the neutrons, you're changing the mass. All right. And that's exactly what we saw here. This had a mass of 9. This had a mass of 10 because it had one more neutron. Okay, so these isotopes, you'll see them annotated and written out in a couple ways. One is pretty basic. You'll see the name with a dash. That's not a negative, just a dash, and then the mass number. Or you'll see it with the element symbol, the atomic number on the bottom left next to the symbol, and then the atomic mass or the mass number at the top left. Okay. So based off of this symbol right here, what is some information that you can get about this particular atom? Right, so you can get every piece of information you need. We know the symbol, H. That tells us that we're talking about the element hydrogen. We see the atomic number is 1. That means that there's 1 proton. And for right now, 1 electron, right? That's what hydrogen has, is 1. If this is the mass number, that means that this number minus our protons will tell us our neutrons, okay? We can figure out all that information, everything that we've been doing for the last 2 weeks, just from looking at the symbol of this particular isotope. So let's check and make sure that we get this. If an atom has a symbol of aluminum-28, all right, or this other version of the symbol, what is the mass of this particular aluminum? The mass is that 28. Now, using that and our knowledge that the atomic number is 13, how many neutrons does it have? Yep, 28 minus 13 is 15. All right, so now let's look at the other variation on an atom. So identify again, what are some things that are the same and what are some things that are different? So once again, what is the same is these 2 atoms are both beryllium. They both have 4 protons. This time, they're both stable and both have 5 neutrons, and they both have a mass of 9. Now, what is different is that this one had 4 protons to balance out 4 electrons to balance out the 4 protons. Down here, it's lost 2 of those electrons. It only has 2, so it doesn't balance out with the 4 protons. There are then 2 more protons than there are electrons, so that is why it is labeled here as a positive ion with a +2 charge. All right, so like I just said, when you have an imbalance in the number of protons and electrons, when they're balanced, it's neutral. If they're imbalanced, that it becomes a charged atom, which we call an ion. If there's more protons than electrons, it's got positive charge. If there's more electrons than protons, then it's got a negative charge. Okay, the key though is you can't change the protons, because if you change protons, then you change the atom. We are just changing the electrons to make it a positively or negatively charged atom. So you'll see this symbolized really just pretty basically with the element symbol. Here you see the mass number and the atomic number listed right there. They may or may not be there. But if you see up to the top right, if you see a plus or minus with a number, that means it has a charge. All right. And that means that there is an imbalance in your protons and your electrons. All right. And just by knowing the protons, by knowing this +2 charge, you can figure out how many electrons it has. We're going to spend more time with this next week. And you're going to explore it in your 2 assignments. But if it has 12 protons and a +2 charge, that means there's 2 more of these than there are electrons. So there's got to be 10 electrons. All right. So what information or can you predict, are there more protons or electrons based on this symbol? So there's definitely more protons because it has a +2 charge. All right, again, thinking here, there are more protons. There's 4 protons, 4 electrons. Down here, there's 4 protons, 2 electrons. There are more protons, and that's why it has its positive charge. All right, so let's check for understanding. If an atom has an if this atom fluorine has a -1 -1 charge, do you think there are more protons or electrons? There are more electrons. There's an imbalance in towards the electrons because the electrons have negative charge. Okay, what about an atom if it has 16 protons and 18 electrons? What do you think its charge is going to be? there are 2 more electrons or 2 more negative things than the protons. So it would have a 2 minus or negative 2 charge. All right, so I'm going to walk through very, very quickly the 2 assignments that you guys have this week. So the first is number 48, isotopes and ions, build an atom, Colorado PhET. So this is an assignment that you guys worked on. Kind of. We've changed it a little bit differently. So this, the Colorado PhET itself, though, is one that you guys have explored before. So what you're going to do is use the specific instructions on the handout to build some different atoms and to see what happens as you change different parts of that atom and record information about it. So if we go here, we have hydrogen with 1 proton and 1 electron. If we go over to that to the build an atom tab, okay, if we go over here, I'm going to reset it and clear it out real quick. And we're supposed to build an atom with 1 proton and 1 electron. All right. On the other slide, it asks, or on your worksheet, it asks you to record, is it a neutral atom and does it have a charge? Nope, sure doesn't. This is neutral because we got to think about it. There's 1 proton and 1 electron. Now, if we are to, and it's stable. If we are at a neutron, okay, what happened? It's still neutral. It is still stable, but now it has 1 proton and 1 neutron. Those 2 things add together to tell you your mass. So the mass up here is actually to 2. All right. So if we're going back to this, if we go back, we can say that they're both hydrogen atoms. The first one had a mass of 1. The second one had a mass of 2. They were both stable. In the isotope notation, all you need to do is write the name with a dash and then the mass number. All right. So hydrogen 1, hydrogen 2. And I would predict that this third one, because it still has 1 proton, it's probably still going to be hydrogen. It's going to have 1 proton and 2 neutrons. So I think its mass will be 3. I think it will, I don't know, I might guess it'll be unstable. But over here, the symbol will be hydrogen 3. And let's see what happens if I add 1 more neutron to this. There you have it. It becomes unstable. The mass becomes 3. Okay? So that is one of your assignments. You'll also be exploring what happens if you get rid of electrons, right? And what does that do to this whole atom? That's what you'll be doing for the isotope part. So a specific part of the isotope section that I want to make sure I bring up with you is that it has you label cation or anion. So as you go through and make these variety of atoms, if it's an ion, if it has a positive charge, it's a cation. If it has a negative charge, it's going to be an anion. And with the ion notation, all you need to do is, if you can go and find the superscript. I believe it's usually somewhere on here, but I can't see it right now. But you can do the superscript by doing Control period, and then you put the charge to that right corner. If you can't figure out how to do that, it's totally fine. Just write H plus 1. I'll know what you're talking about. Okay, so that is the assignment number 48. The assignment number 49 is going to be a quick way for you guys to practice using the information about different elements to do to make the symbols. So Mr. Rychek made this really cool document that is like self-checking. So if an answer is put in incorrectly or left blank, it will turn red. If the correct answer is put in, it will turn green. So this atomic mass, we have to look at our protons and our neutrons. That is 14 if I add those together correctly. Again, when I put that in, it turns green. The electrons, there is one more electron than proton, so it has a -1 charge. Again, that's right. The atomic number is your proton. This is an ion because there's a charge, and this is an isotope because the atomic mass is different from the average atomic mass. All right, again, following the same protocol over here, the protons tell my atomic number. If I put 1 in there, green, yes. All right, the atomic mass is my protons and my neutrons. 1 plus 0 equals 1. Put that in. Yes. The charge, there are 2 electrons that are negative and 1 proton that is positive. So if there's 1 more negative than there is positive, it has a -1 charge, 3 for 3. Now, is this an ion? It is an ion if anytime it has a charge. So if you just simply put yes in that box, turns green. Is it an isotope? Compare the atomic mass to the average atomic mass over here. No, turns green, killing it. Okay, so that is the second assignment for you. If you go onto Google Classroom and you scroll to your week 11 assignments, you will see that there are then the 4 assignments for this week. They should all be done by Sunday, ideally. Okay, so to finish this class out, let's do a couple really quick check for understandings. So, what is the atomic number of this? Yep, so that bottom 17 is what you're looking for. What is the mass? It is 36. What is the charge? -1. All right, so I'm sending you out to complete the previous 2 weeks or 2 assignments for the week if you haven't done that, and then these 2 new ones that were just posted for you, number 48 and 49. Have a great rest of your week and nice weekend, and I'll see you guys later.